fuel oil properties. So specific, okay, whenever talking about fuel oil, there will be viscosity, there will be specific gravity, there will be ignition quality, there will be pour point, cloud point, flash point. So these definitions you should know. Again, amount of hydrocarbon and other properties also required, but the basic physical definitions also you should know. So specific gravity, the weight of a given volume of fuel as compared to the weight of an equal volume of water. That ratio is called specific gravity or relative density. So sometimes we specify this one with degree API. Okay, viscosity, the resistance of fluid flow, fuel to flow. Okay, any fluid flowing, if high viscosity means flow rate will be lower. Okay, if a fuel is highly viscous, it requires heating to make it flow. So many times HFO or HFO fluid, heavy fluid you are using. So in that case, you may have to increase temperature so that your viscosity will be reduced and it will be flowing inside the cylinder. Viscosity measured using instruments such as redwood, Seabolt, or other viscometers. It's called viscometers. Viscometers. Okay, which use flow time for given volume of fuel. Ignition quality or airflow. The time delay between injection and combustion is called ignition quality. So simply flash point, a crucial figure used to determine the highest safe storage temperature of fuel. Okay, if flash point is lower, so at lower temperature it is giving lots of vapor. So in that case, that will be dangerous because the vapor will be mixing with air and it will be creating combustible mixture. So that will be if there you get any small fire source, that will be complete disaster. Okay. Pour point, slightly above the temperature at which the fuel flows under its own weight. It is the lowest temperature at which the fuel can be easily handled. So let's say you are moving with ship from Chennai to Alaska. So Alaska temperature will be very low. So in that case, what will happen if you do not consider the pour point? Maybe your fuel will be frozen, or maybe some wax particle and other particle will be settled down, and some liquid will be on the top and other particle will be settled down, or it will create hazy mass. So that injecting that fuel inside the cylinder will be problem. So you have to, whenever you are using certain fuel and you are traveling from one country or one geographical location to another geographical location, so in that case you have to see whether it is having proper flash point, proper pour point, proper cloud point. All these things you have to consider. Okay, so let's say from you purchase certain fluid and in Chennai it is giving higher because temperature is higher, so it is giving more vapor, fuel vapor. So the fuel vapor will be mixing with air and your weight loss of fuel will be there, and again it will be a dangerous situation if it is going into the atmosphere. LCV, HCV, sulfur. Okay, LCV means lower calorific value, HCV means higher calorific value. Lower calorific and higher calorific value. So LCV, higher calorific value means HCV. Okay. The carbon residue from forming property of a fuel is measured using the Conradson's method. So sulfur content, S means sulfur. Sulfur content is important as it causes engine wear. Okay, considering sulfur content is important as it causes engine wear. Fuel specification include a maximum percentage of sulfur content. A fuel calorific value is the heating value or how much heat is getting released from a fuel after combustion. Okay. Two values are used normally. The terms you should remember: higher calorific value, lower calorific value. Lower calorific value means lower LCV measures available heat energy and does not include heat energy contained in the steam produced during the combustion. So fuel can have water particle, a certain amount, certain percentage. Now you are burning the fuel. What will happen? Water will be getting latent heat and sensible heat, and after combustion that heat actually it will not give you any value. Water will take that heat with it. Okay, so if you have higher amount of water content, that means water will be taking lots of latent heat and it will go away with your exhaust gas. So if you have a fuel with lower amount of water or H2O vapor, so your life is better. Okay, so LCV measure available heat energy does not include heat energy containing steam produced during combustion process. Okay, so whenever you are calculating your how much energy you are getting from a fuel, you have to use lower calorific value. Means higher calorific value, total amount of heat, which include water vapor taking heat also. Now, if you remove total heat you got minus the water vapor taking heat, so that much heat actually your usable heat. So that heat is called lower calorific value. So that heat you can use for your calculations. Viscosity affects jug type injector pump and injector operation. So viscosity is very much important. It is temperature dependent also. If you increase temperature, viscosity will be down. So and if you are changing temperature, so in that case viscosity will change, and your system can fail also, or engine can stop working because it is not flowing into the engine. Okay, so in that case maybe you have to increase temperature before putting into the cylinder. Oil treatment. Oil treatment is essential for both fuel oil and lubricating oil before they can be used for engine. The process of oil treatment involves storage and heating to allow water separation, filtering out solid particle through coarse and fine filtering. Centrifuging action also you have to do. Centrifugal force, let's say if you take certain amount of fluid, okay, and if you rotate at very high speed, because of high speed, different density fluid particle will be creating different layer. For example, there will be one layer, there will be high density, okay, near the center of this axis low density fluid will be getting accumulated. So in that way you can separate the impurities from oil or petrol or diesel or grease or toothpaste, sorry, petrol or diesel or your lubricating oil. If centrifuge is used for separate two liquids, it is known as purifier. If it is used to separate impurities in small amount of water from oil, it is known as clarifier. Okay, so you see the difference between purifier and clarifier. Impurity is small amount of water also, so that's called clarifier. Okay, to remove contaminants, impurities from lubricating oil helps reduce engine wear and possible breakdown. So lubricating oil purpose is to increase smoothness when one rotating surface is there or sliding surface is there. So if they are getting very much high friction, so what happens? In that case, you put some lubricating oil, so it will be moving smoothly. Okay, so it will be reducing wear and tear. But if you have some contaminant, let's say some sand particle or there, so sand particle when one surface is sliding over other or rolling, so that solid particle will be rubbing this any of the surface or both surfaces. So in that case, wear and tear will be more, and your system can fail quickly. Okay. Fuel when burning in combustion chamber, the some terms are used. One term is called stoichiometric ratio. So the ratio is defined as the mass of air divided by mass of fuel. Okay, this is mass ratio. Okay. Stoichiometric mixture, ideal air fuel ratio for complete combustion. The oxidation reaction you can see C8H18. Okay, we'll use the normally this is common fuel for petrol engine. For this one, your air fuel ratio 14.7 is to 1, or stoichiometric ratio actually. If you have more fuel or more air or less air, then your stoichiometric ratio will change. Equivalence ratio, air fuel actual divided by air fuel ideal or theoretical. Ideal or theoretical. Okay, so lambda less than 1 is rich mixture, lambda more than 1 is lean mixture, and lambda is 1, it is called stoichiometric ratio. Okay, and some fuel will have different will have different stoichiometric ratio based on their molecular weight. Okay, you can see this CH3OH, it is having 6.47 air fuel ratio. Hydrogen is having 34.3. Okay, and whenever you are calculating for air fuel ratio, you need to know this molecular mass. So hydrogen is having 1.008 atomic mass unit, carbon 12, oxygen 16, air 23% oxygen, 70% nitrogen by mass is there. But if I consider mole, then 21% mole is there in air, oxygen. So stoichiometric air fuel ratio. So here you see this figure, power, and this is air fuel ratio. Okay, So air fuel ratio, when this curve is fuel consumption curve, fuel consumption, this is called power curve. Okay, for a gasoline engine, for example, it is given lambda is 1 for this line. Okay, lambda equals 1, and for right side lambda equals actual air fuel ratio 14.7 is to 1, but right side of this lambda equals 1 is value, for example, it is given like 15.4 is to 1 and lambda equals 1.05. This is A by F. Okay, but left side here is given like 12.6 is to 1 A by F air fuel ratio, lambda equals 0.86, and maximum power you are getting here. Okay, but here best fuel economy. Okay, what happens if you have little bit higher amount of air? So your fuel will be complete, it will be burning completely and it will be giving maximum power and your fuel economy will be better. But if you have less amount of air, so in that case what happens, you get maximum power but your air consumption low, so maybe some pollutant gas, carbon monoxide, other gas will be produced. Okay, so your tendency will be to give some small amount of extra air so that combustion will be proper, if your economy will be proper. But when this maximum power scenario comes, let's say one bike is designed for 2 person and 3 or 4 students riding, okay, uh, on a bike. So in that case you need maximum power, but your engine volume, cylinder volume is same, and you are having, instead of 2 person, you are 4 person riding on the bike. Okay, so bike will be requiring more power. So in that case what you do, you get more fuel. So some fuel will be unburned from tailpipe, some petrol smoke, you can see white smoke will be coming and it will be making noise also. So in that case you are getting less amount of air, you are getting more amount of fuel, so some fuel will be unburnt, but it will give you maximum power. Okay, but if economy, so many cars and vehicles, they will be marking this economy zone. Economy zone means there little bit extra air will be there inside the cylinder and combustion will be proper, so that time fuel economy will be better. But overloading engine or some other condition you create where you need maximum power, there you have to give more fuel, air will be lower, so more fuel is there, that is called rich mixture. Okay, less fuel is there, it's called lean mixture. Okay, so this vertical line is there at the center, left side is rich mixture, right side is lean mixture. Rich mixture will have power higher, air amount will be lower, but pollution will be more. But lean mixture, fuel economy will be better, power will be little bit lower, but your environmental the issues will be less. Okay, let's assume one fuel, methane. So methane will be reacting with oxygen, it will be producing carbon dioxide plus water. Okay, so atomic weight of C is 12.1, hydrogen 1, oxygen 16. So molecular weight of methane 12.1 into 4 hydrogen, 4 into 1, so 16. Oxygen, 2 oxygens, oxygen is used. Okay, so we are getting 32 molecular weight. So oxygen by fuel ratio, this is not air fuel, this is oxygen by fuel ratio. So 2 into 32 is 2 oxygen molecule is there, and fuel molecular weight 16. So totally you are getting 3.997 or 4%. Stoichiometric ratio, air fuel ratio 3.97 divided by 23.2. 23.2 is coming from that oxygen is there in 23.2 by weight percentage. Okay, so air fuel ratio is coming 17.2. So each fuel have their own air fuel ratio. Okay, so here this figure C8H18, this fuel is having 14.7. Okay, this is actually basically petrol engine. So another problem, equivalence ratio lambda equals 0.7 for ethane combustion. Calculate percentage. Ethane means C2H6. Okay, so C2H6, if you react with oxygen, then 2 C2H6 will be required, 7O2, 4 CO2, 6 CO2. So oxygen fuel ratio. Oxygen here you can see 7 and fuel is 2, so ratio is 7.2. By weight is 7 into 16, 2 into 30. 16 means oxygen molecular weight and 30 means C2H6 equals 12 into 2 plus 6 into 1, so 24 it is 30. Okay, so you are getting the ratio 28 by 15. Stoichiometric ratio theoretical 28 by 15 into 100, so you are getting 8.11. So air fuel ratio actual by air fuel ratio theoretical. Okay, so you are getting lambda. So if you solve this one, finally you are getting excess air is 30%. So another problem you can see C8H18 again, oxygen, nitrogen. Okay, first you have to balance the equation and calculate theoretical air fuel ratio. So to balance this one, actually you have to put C8H18 plus 25 by 2 oxygen plus 3.76 nitrogen equals 8 CO2 plus 9 H2O plus 47 N2. Okay. For balancing 79 by N2 by 21%, so that is giving actually 47 N2. Okay, theoretical airflow ratio. Mole, not weight, this is mole. So 25 by 2 mole oxygen plus 47 mole nitrogen divided by 1 mole C8H18. So this should be giving 59.5 mole air divided by mole fuel. Okay, so theoretical airflow rate, airflow ratio. So theoretical airflow ratio equals 59.5 into 28.84 by 1 into 114,151 kg of air divided by kg of fuel. So this is your solution. So thank you very much for today's lecture. Next day we will start new topic. Thank you.